Assalamualaikum warahmatullahi wabarakatuh. We are Group 7 from Lecture 12 and today we will be presenting about copper as electrical and thermal conductor. But before that, we will be introducing ourselves first.
Hello, my name is Nur Athirah binti Mohd Yusof, matrix number AS11535.
Hi, my name is Syahirah binti Halmee. My matrix number is AS11863.
My name is Muhamad Azhar Zuhairy bin Jumadi, matrix number AS12025.
Amir Safwan bin Madzlan, matrix number is AS12249.
Okay, without wasting any time, we will continue with the presentation. Okay, for introduction, the word copper comes from the Latin word cuprum, which means ore of Cyprus. This is why the chemical symbol for copper is Cu. Copper has many extremely useful properties, including good electrical conductivity, good thermal conductivity, and corrosion resistance. But for today, we will be presenting just the two of them, which is good electrical and thermal conductivity. The properties of copper: it is easy to alloy, hygienic, easily joined, ductile, tough, non-magnetic, attractive, recyclable, and catalytic. Okay, for good electrical conductivity, copper has the best electrical conductivity of any metal except for silver. Copper wire can be wound into a coil. The coil will be produce a magnetic field, and being made of copper won't waste much electrical energy. Copper coils can be found in electromagnet. It is used in scrapyard cranes and electric bells, and then made in motors as a domestic appliance like washing machine and dishwasher. In dynamos, for example, bicycles and power stations, and lastly in transformers, which is mostly found in electricity substations. So, how copper conducts? Copper is a metal made up of copper atoms, which is closely packed together. If we could look close enough, we would see that there are electrons moving about between the copper atoms. You could see it as the figure 1. The green one is the electron. It's moving freely. Each copper atom has lost one electron and becomes a positive ion. So, copper is a lattice of positive copper ions with 3 electrons moving between them. The electron can move freely through the metal, and for this reason they are known as free electrons. They are also known as conduction electrodes because they have copper to be a good conductor of heat and electricity. The copper ions are vibrating. Notice that they vibrate around the same place, whereas the electrons can move through the lattice. It is very important when we connect the wire to a battery. So I will pass the presentation to Syahirah. Syahirah, could you please continue?
Thank you, Azhar. So I will continue to discuss about how copper conducting electricity.
Wait a minute. What if before Syahirah starts to explain, all of us guess how copper conduct electric?
I think that's a great idea. Let's see if you guys can guess it correctly or not.
In my opinion, since electrons have negative charge, it will move to positive terminal. This causes ions to vibrate.
Syahirah, I'm a bit confused how electrons and ions produce electricity. Can you explain it to us?
Okay, sure. Firstly, we can connect a copper wire to a battery and a switch to form a circuit. Then, if you guys can see, the figure 1 shows the movement of the particles in the copper atom. Then, after we connect the wire, we need to close the switch and electric current started to flow. Now, the free electron, just like in figure 1, moving towards the positive terminal of the battery, and the movement is from left to the right. When there are a movement, the copper ion in the wire are vibrating. Next slide. Okay, why is it vibrating? It is because the copper ion are blocking the path of the moving electrons. Then the electron will collides with the ion. The collision that happen between the electron and the ion make the electron speed slows down. It is because the energy of the electrons has been transferred to the ion and make the ion vibrating. The transfer energy also make the copper gets hotter, and it's explain why metal have the electrical resistance and get hotter when current flows through them. Is it clear?
Oh, that's how it works. For this slide, I just memorized it. It is stated in the textbook. By the way, thank you, Syahirah.
Okay, welcome. So we go to Amir.
So now I will be explaining about good thermal conductivity in copper. So copper is a good conductor of heat. As we can see in the table below, the relative conductivity of some metals can be seen in the table. So copper has a high relative conductivity of heat, only to be exceeded by silver. But even though silver has a higher conductivity, we use copper because copper first is more abundant, and copper has less risk of getting oxidized and losing its function rather than silver. So next, the application of copper is seen in many devices such as copper plate, where copper is used as the saucepan bottom, and in copper pipes, which is used in heat exchangers in hot water tanks, underfloor heating systems, or whether football pitches and car radiators, and in heat sinks, which is used in computer disks, drives, and TV sets to let the heat flow from the electronic component. Copper is most used instead of silver because first, copper is much more abundant than silver, which means it is easier to be found, and silver actually has a risk of getting oxidized and losing its conductivity. So in the long run, it might be better to use copper rather than silver.
Next, let's learn how a copper conducts heat. A copper is made from a lattice of ion with free electrons. In figure 1, you may notice there are green dots and red dots. The green dots represent electron, while the red dot represents ion. In figure 3, there is only red dot, which is ion. And figure 3, it shows what happens when one end of the piece of copper gets hotter. The left side, which the ion vibrates more, is the hotter end, and the right side is the cold end. When the left side of the copper gains heat, the ion at the left side will vibrate energetically, and at that moment, the free electron which will pass the left side will hit the ion, and it will collide at the hot end, and the electron itself will gain kinetic energy and it speeds up. From hot, it will reach the cold end, and it collides with the cold ion, making the previously cold ion vibrate more. This heats up the cold end. In this way, energy is transferred through copper from hot to cold. Next is about how a nonmetal conducts heat. We can compare this with how a metal conducts heat with how a nonmetal conducts heat. In a nonmetal, the vibrating particles pass on the vibration to their nearest neighbors, and their neighbors will pass on the vibration to the other neighbors and to the other neighbors. This is much slower. That's why metals are the best conductors. Their free electrons can carry the energy along their length. That's all from me.
In summary, copper is a good electrical conductor and thermal conductor. During the journey of electrons collision and frequent contact occur between electrons and ions in copper lattice. This causes ions to vibrate. As a result, ion gains kinetic energy and copper will get hotter. In other words, electrons and ions contribute to the ability of copper to be the best conductor of electricity and heat. So yeah, that's all from us. I hope our mini talk helps to enlighten our audience's understanding. Copper as electrical and thermal conductor.